So in this video, we'll look at the method to find the volume of a solid by the disk method. It is a continuation of the last video, but now in this video, we'll focus on the region on the XY plane, but I'm trying to change the axis of rotation to the Y axis. Please look at the current case here. If I ask you to rotate such a shaded purple region along the Y axis by 360 degrees, can you imagine what kind of solid you're getting? So after rotation, I trust that you're able to imagine what you have in your mind. You're actually getting a full solid like this. I would like to emphasize that it is a full solid in the sense that you can imagine that such a container is full of the purple liquid now. And of course, I would be interested in finding the volume of such a picture. And please recall the disk method. The fact is that we have to look at the cross-sectional area of such a picture. And for the current case, the cross-sectional area is actually based on an horizontal line, which is a red line here. And please look at the position of this line. This line is based on a point on the y-axis. The lowest such line, of course, is based on the point A here on the y-axis, and the uppermost line is based on this point B here, right? So please imagine, for example, let's take a look at this point. When you rotate this horizontal line horizontally by the y-axis rotation by 360 degrees, can you imagine what you're getting on this solid? You're actually getting, after rotation, a red disk, which is a full red disk inside the solid here. And if you recall the method how we wrote down the volume formula for the solid generated by the x-axis rotation, I think we can also write the answer down here. You see, the fact is that the volume formula first. If you recall the fact that we can think of the volume as sum of area of such a disk, right? But now, please see the position of the disk. It is located horizontally, which means that the lowest most disk is the disk here, which is based on the point A here on the y-axis, and the uppermost disk is here, right? So you have to go through all the disks from the lowest point to the upper point, which means that it's actually an integration along the y-axis because the area of disk now is from y equals A to y equals B, right? And it means when you write the volume formula down here, we expect that you have to do the y-axis integration from A to B. Please note that both A and B are now sitting on the y-axis. And same as what we have discussed before in the previous video, the content inside the integral should represent the area of a disk. And the area of a disk is like the pi r square. And please think about the meaning of r. And the r is actually the length. Please look at this black line, the length from the y-axis up to the point sitting on the curve, right? This is the horizontal length that we want to look at for the meaning of r. And this length is what? If you look at this point, which is on this curve, this horizontal length is exactly the x-axis, I mean the x length, based on the x-coordinate of this point. I hope you agree with me. In that case, it means we can write it as g of y, where g of y is what? G of y is the transform that you have to make based on the curve y equals f of x you have. You have to transform this curve to the correct form in the sense that x is the main variable on the left-hand side, and the right-hand side, you only have the function of y. So basically, after doing such a transform, you have to do a y integration for this case. And let's look at some examples. Please look at the current picture here. And if I ask you now to rotate this shaded part along the y-axis, please imagine what kind of picture you're getting. So after rotating the picture along the y-axis by 360 degrees, I expect that you're getting a full solid here, and I would like to ask for the volume formula of this solid. And please recall the fact that from the previous page, we understand that the volume is gonna be a y integration now. And for you to memorize this concept in a more awkward way, the fact is that for the disk method, if the axis of rotation is y, it's always correspond to a y integration. And in the previous video, we've seen it already. If the axis of rotation is x-axis, it's always the x integration, right? And now, let's take a look at what is the content inside this integral. It should be something like pi r square. And let's look at the upper and lower limits. The upper and lower limit is based on what you can see on the y-axis from the lowest point to the upper point, because you're integrating along the y-axis. So it should be 1 to 8. And let's come back to this part. This part means the r, which is the radius of such a disk, and the radius is based on the line here, and which is the x length of this point. And if you recall from what I said in the last page, you have to transform this equation into this form where the x is the main variable on the left hand side. And I trust that you're able to do this transform, because if y is the same as x cubed, we can write x as the y to the power 1 over 3, right? And that's basically that what I want. So this is the x equals g of y I want. And this is exactly the g of y. So basically, and that's the end of this formula. And if you want to know the computation, I try to quickly write down the answer here. So please, that's the steps that you need to write down to get to the final answer. And you can easily check the numerical answer by calculator now. And that's the end of this problem. Let's look at one more problem now. Please look at the current picture now. If I ask you to generate a solid by using the current purple shaded part, by rotating such a region by the y-axis by 360 degrees. Can you tell me approximately how's the shape of the solid like? I believe that you can imagine that you're getting a solid here like this on the right hand side. And I would like to ask for the volume formula of such a solid. And please recall what we have. It should be a dy integration, because now is the y-axis rotation, right? And for the dy integration, the upper and the lower limit follows the y-axis from the lowest point to the upper point, which is from 4 to 6. And the content inside the integral should be the pi r square. And this part is about x equals g of y. Please look at the function you have, which is y equals 4x plus 1, right? And I think you can easily make it like x equals y minus 1 divided by 4. And that's exactly what we want in the form of x equals function of y here. So I just replace y minus 1 divided by 4 inside the bracket. It represents the x length of the point here. So it represents that, for example, if you take a horizontal black line here, the length here is exactly the x length, which is x equals y minus 1 over 4. And the y based on this y here. And that's basically the way to find the volume of such a solid. And if you want to know the computation, I can just write it down here to speed up the process. Please look at all the steps here. I trust that you're able to get the final numerical answer based on my steps here. And that's basically the end of this video.